So guys, we are moving to our next step. After overview, it's in tutorial environment setup. Here is some useful information how to do it, but we already did it. Just let's check Scala compiler. Is it written there? We can use any shell or command line Scala -version. Waiting a bit. Aha, we should do it in terminal. Yep, Scala Code Runner version 2.12.2. Nice. So, move forward. Next step is basic syntax overview. Here is as first sentence quite important information that if you already have good understanding of Java, then there won't be a big effort from you for understanding Scala. And the biggest syntax difference between Scala and Java is that the semicolon, line, and chapter is optional in Scala. So overviews: objects, classes, methods, fields, it's all the same. A closure is a function whose return value depends on the value of one or more variables declared outside this function. It's something related to lambda expression in Java, but with more mathematician way, if it's possible to say so. And traits. Trait encapsulate method and field definition, which can then be reused by mixing them into classes. It's something like interfaces in Java with small difference. So that's it. It's almost the same like in Java, but with small differences. There is Hello World examples, and the interesting point that you can do it in like two different ways, in script mode and interactive. We already did it in script mode, so we created like simple application and object for that, but that's it. But let's try to do it also in script mode. For that we need our terminal or any console-like application. We'll use embedded in IntelliJ IDEA, so calling Scala, and then we can call println with some line. Hello Scala. And yes, hello Scala is printed there. So Ctrl C for outing from it, but it's working fine. That's cool. And a bit another way for creating hello world than we used. Here is main method that can generate IntelliJ IDEA without extending of app class. Hello standard mode. It's script mode hello world. So we created two hello world applications during last 5 minutes. That's fine. And unit is subtype of annual. And we will take a look at hierarchy soon. 。 . 。 。 . 。 . 。 . 。 . 。 . 。 . 。 . 。 . 。 . 。 。 . 。 。 . 。 。 . 。 。 . 。 。 . 。 。 。 。 。 . 。 。 . 。 。 . 。 。 . 。 。 . 。 . 。 . If we want to return something from method, we can use unit, something like void in Java. There are some Java docs about that, but let's move forward. So also basic syntax is case sensitive. Code conventions are the same to Java, and that's cool. Program file name with Scala extension. Let's check it. Yes, hello Scala. Scala identifiers. Legal and illegal values, so not possible to start from special symbols, and interesting thing, operator identifiers. Few symbols like few semicolons or plus plus can be used in Scala. Scala keywords, some of them are same to Java, but here are a few new, like lazy, dev, clit, implicit, null is exist in Java, try and var from first letter capital. Okay, fine. So that's a Scala keyword. Keywords. We reviewed them. Try and var. Yes. Funny. Comments in Java. Multi-line comments. Same to Java. Packages. Also same to Java, but with small difference. Here is possibility to import few classes with one import. So that's it, guys. We have went through all the syntaxes basics with you and can move forward. So let's do it. Our next step is going through data types. Data types is Scala quite simple. There is no primitives like in Java, but all the classes. So it's the same to Java. Byte, short, int, long, float, double, char, string, boolean, unit, null. Let's try to check something. While it's immutable variable. So println number. Yes, it's our number. Val and var. Val is immutable type when var is mutable. Value and variable. So here is such syntax. Val number, then value, and then its type. Let's try to check with static code analyzers on our cube. Will it say something about that? Just interesting moment for me. Report. It's clear. Let's convert according to idea suggestion. So that's it. Unit, no. Here is also nothing, any, and any ref. Let's try long type. Incorrect, I think. Because the type should be at the end. Like in TypeScript. There are a lot of methods here for the long type. A lot of them quite interesting. As for Java developer. It is long. Okay. So unit correspondence to null value is something to void. Null or empty reference. And here is one more type, nothing. Subtype of every other type. Really interesting. Let's create a method. That returns unit. Here we should have def keyword for correct signature of method. Yes, method is working fine. So moving forward, no, nothing. Any and any ref. Any is a supertype of any type. Any object is of any type. And any ref is supertype of any reference type. Let's try it with any. Yes, we can find as with unit, because any supertype of any type. Okay. Literals are the same to Java. It's like Boolean true, false. Let's take a look at symbol. It's the same with single quote. Also, there are character literals that can be used with Unicode number, Unicode value. Strings the same. So it's it, guys. We have finished with data types in Scala. Let's move forward, guys. Variables in Scala are almost the same as in Java, but with small difference in syntax. For declaring variable, we should declare first a keyword, val or var, depending on what we need, immutable or mutable value, then variable name, then column, data type, symbol of equality, and then initial value. So that's it. It looks like var, my variable, and equals 10, semicolon, not required at the end. Also, there is a way to declare multiple variables, like it is called here multiple assignment with tuple. Tuple, we will talk about that a bit later during talking about collections, but shortly it's object that allows us to create few variables and put them inside. For example, like in Java, if to talk about entry in maps key value, so that can be used as tuple 2, like tuple with 2 values. We'll check it now, so take a look. IntelliJ says us that pair is deprecated, and it's really true. We should use tuple 2 instead of that for creating key value pair. So let's do it and check what we will get during printing that. So we are creating tuple with 2 values. First of them is integer and second is string, like key value 30 millions. Let's print it now. We can't use our method that we created before for print value because here is string, but we have tuple. So let's use println for that. Yes, we can see in console 30 and millions. Okay, that's it. So the most significant and important information from the chapter is using of 2 keywords, var or val, depending on what you want, immutable or mutable variable. If you want immutable, we are using value, val, and if we want mutable, we are using var. It's like variable. In general, immutable programming is more preferable in most cases. It's more safe, easy to test it, so it should be preferred. Let's create some demo with testing of that variables. So we created immutable variable, and here during reassignment we can't do that. IntelliJ says that it's incorrect, it won't compile. So changing it to var if want to reassign the value. Yes, and one more point, method parameters are always immutable. That means that when we are creating some method and that arguments can't be reassigned inside the method. It allows to use all the features of immutability. And immutability is one of cases, one of points from functional programming. So that's it, guys. So, classes and objects. In Scala, everything are classes, so there are no primitives, as in Java, as boolean, int, long. Here it's everything classes, and their instances are objects. Creating of objects is the same as in Java with keyword new. So let's take a look at it. Here is diagram with example of inheritance. Let's move forward. And here is more interesting example with creating of, to be more correct, with not creating but with declaring class with implicit constructor. So in Scala there is no need to create additionally to declaring variables constructor for initializing them. It can do automatically. So it's something like out of the box in Lombok in Java with all args constructor and like that. And here one more interesting point, it's in the example below. In second with creating class point, if we declare variables in the list like val xc, so that we will add fields to that class, and it's very convenient. We will meet it then in future, but now let's try to check it in the first example. So we are creating in separate file with extension Scala class point. We explicitly declare two variables that are immutable. Semicolon is not required there. We can remove it. Let's make firstly a small refactoring there in our program for more convenient testing, because we want our learning to be clear. So let's extract that code to reusable methods. Let's execute it once more. Here is interesting point. Idea says us that it's not very good to use methods that returns nothing. So with void or unit type as a return one, due to side effects, because there is assumption if method doesn't return something, it somehow do some logic that can have side effects. That means that we should try always to return values for be in immutable programming, but for now it's okay, we can omit that because it's only for printing values and for debug purposes. So let's leave it as it. So you can see that we made our program clearer. It's now separated by the points we tested. So now let's create instance of our class, new point, and let's print it. We've got, we didn't create to string, so it printed hash code with some class information. Let's improve it a bit. Let's create toString. The class itself for now can be not changed. So there was an error if we declare explicitly the variables inside, and if they are immutable, it's like the same to final variables in Java, we should initialize them. For that we created additional constructor with two values. So now it's working in the same way, because our toString not very good. It calls super. It's quite convenient way of declaring methods, so we can override then def keyword and method itself. So, and as the idea says here, return value even not required. It will be automatically done for us. So the code can be written in more fast manner. Running it once more. That's what we need. Here is in the example below, you can see that if we are using like val as constructor explicitly, it will create additional fields to the object that we create. And the default modifier, access modifier, is public. Let's test it, that we can access to the value y. Yes, that's it. Extending a class. You can extend a base Scala class. You can design an inherited class in the same way as in Java, using extend keyword. And override keyword is required if we want to override some methods. So it's the same as in Java. We can do not dive deeper, as it's really clear what's going here. In this Scala there is no multiple inheritance, so we can inherit only from one class. There is an example with extension. Implicit classes. It's quite interesting term that there is one additional keyword, implicit. It was introduced quite recently in Scala, starting from Scala 2.10. Here is the example. So it's declaring of the class inside of object. In the example, let's create an example. It's quite interesting. We'll create the class with loop functionality that will allow us to write code something like 4 times, println hello, and on executing that, it by magic will execute our println method 4 times. Looks really like magic, but it's possible usage of implicit keyword. It looks like recursion, and we should be careful with it. Of course, we should add when we stop executing our condition. If we do not provide such information, we can get like loop for all the time, infinitive loop that couldn't be stopped without force stop of process. Not everything is so simple, because our main program doesn't see the times symbol. Cannot resolve symbol times. Okay, I assume that we should move that to another class. Implicit classes must be defined inside another class object trait, not in the top level. So let's do it. Also, implicit class may take only one non-implicit argument in their constructor, and implicit classes may not be any method member or object in scope with the same name as the implicit class for avoiding collisions. It's not working now. I made small mistake here. In example, it was created in another class. We'll do it right now. But even in such way as I did now, it can be working fine if that implicit class will be visible. So in scope of our main method, we'll resolve it now. but as you can see, it's not so clear from first glance how should it be working, so it's not very readable for Java developers or newcomers to Scala how to work with that implicit classes. So for start, they can be avoided. We created separate class with our implicit class inside of that, and now we should be able to call it. Still cannot resolve, but it's the issue with visibility now. We should add import for adding to our scope that implicit class. So we added wildcard for including that. Yes, and it's working now. At least not red. Let's run it. Tum 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 tum. Whoa, that's magic. Really, 4 times hello printed. It's really cool. Okay. Yes, really interesting, but not very clear. Let's try 2 times. Yes, it's really working correct according to the argument what we provide here. There are also singleton objects, so-called in Java. Singleton is a pattern from Ganko 4. It's creational pattern for having only one instance of some class, only one object in the whole system. And with keyword object, during creating our hello world or the demo, we created object, and it's the single one in whole program that we have. It's like easy way to create singleton without diving into the details how it's working and how it's created. It's really convenient. Let's make final refactoring for having clear separation of what we write. Let's executed, we should have clear output. Let's add one empty line between our different tests. So yes, that's it. We finished with classes and objects in Scala. We reviewed standard creation of classes, we reviewed singleton and implicit classes, and can move forward. So let's go. And let's go through the access modifiers in Scala. So there are private, protected, and public access modifiers. By default, all the access modifiers are public. That's the biggest difference with Java. So it's really clear: public, private, and protected. Public access for everyone, protected for the people who inherit, who extend me, and private is only in scope of that class. And here is one more interesting thing called scope of protection. So access modifiers in Scala can be augmented with qualifiers. It's for more use of encapsulation. So it allows us to restrict some access. So guys, that's it. We have discussed access modifiers. And now let's take a look at operators in Scala. There are arithmetic, logical, bitwise, and assignment operators in Scala, like in any C++ like language. So it's the same like in Java. If you know how it looks in Java, you know how it looks then. With small remark, the double same operator means check of equals. It calls equals method. So cool guys, that's operators.